this is our headquarters in Florida, and I'm part of USA Scientific, and we're gonna be talking today about the mixture AC. The H stands for heating, the C for cooling. We're gonna talk a little bit about the applications and do a live demonstration of the programming settings. The mixture AC. Here you can see a thermocycler right next to the mixture HC. You can see how much smaller it is. So the footprint of the mixture AC is a lot less than the thermocycler, for example. And that helps you visualize how much more space you can save with the mixture with the mixture AC. It has capabilities to control temperature, speed, and mixing intervals, heats samples up to 99 degrees Celsius, and cools them down 13 degrees below room temperature. And that is, if you're in the laboratory that's set at 25 degrees Celsius, it can cool down your samples to 12 degrees Celsius, which is very functional for most of the applications that are used in the laboratory. It has a digital displays, a chore mix function that we're going to talk more about it, the interval feature, and you can alternate between mixing and pulse cycles. It also has a two-step protocol that you can do in the mixture AC, and it becomes very handy in a lot of experiments in the laboratory or reactions that you set up. Some of the specifications, it goes from 300 to 1500 RPMs, and it depends on the block. It has a heating rate of approximately 5 degrees Celsius per minute. So it has two Peltier elements. Peltier elements usually are used in thermocyclers. Thermocyclers have 4. The mixture AC has only 2 because it doesn't have to cycle like a thermocycler. So, but it's very effective. We know it's a very reliable machine because we have thermocyclers in the laboratory. Most people do. The main connections, it goes from 100 to 240 volts and 50 to 60 hertz. So if you have to let us know which plug you need so that we can actually provide to you the machine with the correct cord. The mixture AC is quiet and convenient. There is 3 things that I like to talk more about than anything else. First, it's very easy to clean. So if there's a spillover, because it's all digital, there's no analog buttons. It's really easy to clean. It has the interval function, so you can actually program an interval mix. And it has the programming settings, the 2-step program settings. And it also has the ISO rack, which I'm going to talk a little more in the next slides. Here you can see the ISO rack. And when this is very helpful is when you're doing transformations of bacteria, right? You're transforming plasma into these bacteria and you're handling 24 samples at a time. You can use the ISO rack and put it on ice, all 24 samples in the ISO rack, and then put them in the heating block or in the mixer AC and do the heat shock pretty quick. You don't have to take sample one at a time and transfer them to the mixer. So that's very, very helpful. And it should increase the efficiencies of transformations in the laboratory. Also saves you a lot of time. It has 10 blocks that are compatible with most used vessels. So it goes from PCR tubes, PCR plates, up to 50 ml tubes. So you can buy water, whichever block you need, depending on the application you're using, to do the assays that you're performing in the laboratory. But this adds a lot of versatility to your laboratory. There's a lot of applications that this can be used, right? There's a lot of things that we can talk about, but I'm going to talk about 3 main applications that I think involve all the functions that we talk about. The first one is isolation of lung endothelial cells. If you're isolating primary cells, this is very useful, especially in this step right here. This step right here calls you add collagenase to the cells, and you put them at 1 hour at 37 degrees Celsius. And every 15 minutes, you have to take the 50 ml tube from the water bath and mix it up and down 5 or 6 times and put it back. You can do that in the mixture AC, and you can set it up to do it automatically so that you don't have to be hands-on on the experiment. So that saves you a lot of time. The other thing that I didn't mention is that because you're not working with water bath, if you work with a mixture AC, you don't have to worry about contamination issues that come with the water bath, like adding algicides, biocides, or things to keep uh, the water bath free of these contaminants. The other application is the transformation of bacteria cells, which a lot of people know. The transformation of bacteria with plasmids. A lot of you do this in the lab, and you know that you use the ice. You have ice, you have a heating block, you have a water bath, you have a shaker, and you have the incubator. Well, a lot of these things right here can be substituted with the mixture AC because it mixes samples. It reaches temperatures of 37 degrees Celsius, and it can mix for 1 hour. So you can do all the phases of the entire transformation process in this machine. And the third application is the reverse transcription. Usually you add the primers first, you wait for 10 minutes, right, at 70 degrees Celsius. Then you add all of these components, and then you do a two-step cycle, two-step protocol to transcribe the RNA into DNA. You normally put the sample 42 degrees Celsius, 15 minutes, and then the next step is 95 degrees Celsius for 5 minutes. This step is the RNase H step, and new reactions now don't even have to do that step. You can do it just in a two-step protocol. So you can do all that reaction, this first strand synthesis, the reverse transcription completely in the mixture AC without any problem. So how does it help better than a heat block, water bath, and the vortex? Well, you have multiple steps in one small footprint, right? You have the capacity of heating, cooling, and shaking all in just one machine that has a small footprint. So it substitutes the water bath in these cases that I presented to you, the heating block, and even the vortex in some cases. It has internal mix function, multiple blocks. I mentioned the 5, 15, and 50 mLs because a lot of other equipment don't have that capacity. It's more eco-friendly, and the reason why I said that is because the water bath, you have to keep up with it, and you have to, in order to do that, you have to add algicides and biocides, things that normally you don't count that in the cost of the equipment, but you really have to keep up with that. And with the mixture AC, you don't need to use those chemicals or anything like that, and you don't have to worry about the water evaporating and having to refill, have a student in your lab come back and add more water to the water bath. And that decreases the risk of contamination in your samples. More importantly, if you're working with primary cells, which are really hard to get, and you don't want those to get contaminated for sure. So now what we're gonna do is I'm gonna give you a small demonstration of the equipment. If you can spotlight my camera, can you spotlight my camera, Steve?
Yep, if you could just stop sharing so we could get you in full screen too, that'd be awesome.
Okay. Stop share. Can you see the machine?
Yep.
Yeah. Okay, so that's the machine. I have the machine here with me. I'm gonna highlight the big block. That's the 50 ml block. It's really easy to take off. This is the tool that comes with the equipment. There's only 2 screws here. Really easy to come off unless someone else tries to be Hercules and tie it really tight. It's really easy to change. This is the 50 ml block. It has capacity for 8 tubes. And the nice thing is that this only goes in one direction. So you can't get it wrong. You can't put it the other way because the system will not allow you to do that. You have to put it only one way that it perfectly fits. We're gonna screw this quickly. There's only 2 screws. And now I'm gonna highlight the digital display. Can you see the digital display well?
Yes.
Okay, perfect. You can see that it recognizes automatically the block. So if I had the other block, it would have had, say, a 50 ml block. So the first protocol that we're gonna do is we're gonna do an example like if it was reverse transcription, but we're gonna set it up at 30 degrees Celsius for 1 minute, and then we're gonna go to 35 degrees Celsius for another minute, and that's gonna be the program setup. So we're gonna click here where it says program. Can you see program?
Yes.
Okay. So I'm gonna click on it. The light turns red. You see that little dot right there? That means step number 1. So we're gonna adjust the temperature to 30 degrees Celsius. This is the temperature that you are actually adjusting the machine to go to. And this is the actual temperature right here. This is where you adjust the time. So you can see that set up at 1 minute already, but you can go up to an hour. You can go even past an hour. We don't gonna do anything for the RPMs. The RPMs are right here, but we don't need to mix anything. And this is the interval function, so we're gonna just leave it off. We're gonna click again on program. Can you see there are 2 dots now?
Yes, sir.
So that indicates that that's step 2. So what we're gonna do, we're gonna actually program step 2 to go to 35 degrees Celsius. You can say I programmed to go to 35. Right now it's going up to 33, the actual temperature. And this is to adjust the time. I want to adjust it to 1 time. In your case, you would go 42 degrees Celsius for 15 minutes, and then you would do 95 degrees Celsius for 5 minutes on the second step. Now to start the program, simple, you're gonna hit, I'm gonna go back to step 2, 0 RPMs, because we don't need mixing, no interval function. We go back to step 1 and we click start. And that's it. If we go to 30 degrees Celsius for 1 minute, and then it's gonna do 1 minute for 35 degrees Celsius. So the other program that we're gonna do after this is the intermittent function. Like if you were doing the primary cells work that I talk about, that goes for 1 hour, 37 degrees Celsius, and you're mixing the sample every 15 minutes. Some protocols even call for every 7 to 8 minutes, so that will be even more hands-on. But in this case, I'm gonna do it just for the demonstration purposes. I'm gonna set it up at 1 hour, 37 degrees Celsius, and then I'm gonna do 10 seconds pause and 5 seconds mixing, okay? And for that, we don't need the programming function. So I'm gonna turn it off. You see now that's going to the second step and it's beeping, the 2 steps is blinking. But I'm gonna stop it to go into the other setting. So I'm gonna turn off the programming function. And now what I'm gonna do, I'm gonna go to 37 degrees Celsius here. You can adjust the time. You can see how it changed the time, right? So I'm gonna leave it for 1 hour, 37 degrees Celsius. And I'm gonna turn on the interval function, which is about on that's right there. You see I turned red. Okay, so can you see that upside down U that I'm pointing?
Yep.
Okay, so when it's pointing down, that is the mixing time. So what I'm gonna do, I click again. When it's blinking is when you can actually adjust the time that is gonna be mixing. So now when I click down, you can see that the seconds are changing here. So I'm gonna set it up at 5 seconds just for the purpose of this webinar. And then I'm gonna click again and you can see it looks like a U now, which is gonna be the pause time. It's set up already at 10 seconds, but I just wanna show you that you can change it to whatever time you want to change it to. Okay, so now we're gonna start the program. It starts by mixing. It's supposed to do that for 5 seconds. And then it goes for 10 seconds pause. In your case, if you were doing the experiment I used to do with the primary cells, you would go for every 15 minutes, you will have it shaking at least for 1 minute. And it will be hands-free. And once the machine it finishes, it beeps. it beeps pretty loud, so you will be able to listen that your reaction is finished, it's completed. So, any question? I see 4 chats.
Yeah, there's one question that that Garrett kind of answered, but how does the mixing speed compare to the Vortex mixer? Just if you could elaborate on that.
Well, it's not a very, it depends on the block, right? And the Vortex usually is for very harsh mixing. Like when you want to break something, right? That's when you usually use the Vortex. But I think it's pretty comparable. I think it's pretty comparable depending what uh, speed you use in the Vortex, because you can also adjust the Vortex speed.
All right, if there are any other questions, you can throw them into the chat, or you can unmute yourself and ask away if you'd like.
Can you see the mixing? The machine mixing? Yeah.
Okay, we have one here, Leonardo. How do you adjust the Vortex speed, and could you please demonstrate the highest speed with this block?
With this particular block, it recognizes which block is in. I'm gonna turn on the function, and I'm just gonna do mixing. So that's a 1400 RPM. Let's see. Can you see it mixing?
Yeah,
That's
looking
a
good.
14. Yeah. It looks pretty good. I know some machines that some Vortexes actually a 1400 RPM shake the whole thing, and they even vibrate very hard. This is not, if you, we are on a camera, so usually noise is amplified, and you can see that it doesn't sound that loud.
Awesome. Thanks, Margaret. Next question from Catherine. Is it possible to set up a constant mixing?
Absolutely. Constant mixing. Yes, that's exactly what we did. So right now it's set up at 1400 RPM. It's at 1 hour for 37 degrees Celsius. You can actually click start and we go for 1 hour mixing. So it will mix for an entire hour. And that it's without even using the programming function, two-step programming function.
There you go. All right, thank you. Thanks, Catherine. And then next question, can we use the mixing with an overnight constant heating, as in a proteinase K incubation?
I don't see why you can't. My understanding is that you should be able to do it.
Awesome. Anything else that anyone would like to see, or anything you have to add, Leonardo?
Well, I thank you so much for this. I think it's really nice. I had an opportunity to show you two of the most complex protocols, right? That how to program them. There's probably to do a lot more stuff, but I think I wanted to have something that it was application based. So those are two of the 3 applications that I found that's very useful, and I think it can do a lot of things in the laboratory that, like I say, you normally have the water bath, the incubator, the heating block, right? And all of these things that can be replaced with this equipment. And honestly, the price is a pretty good deal for the amount of functionality you get.
Good stuff. One last question that came in. Do you need to keep a thermometer in it to check the temp, and can it be calibrated?
I would have to check if it can be calibrated. The thermometer is always a great idea. I don't think it's a mixer, so I would not keep the thermometer all the time, but I would keep the thermometer handy so that you actually check the temperature and make sure that it's functioning correctly, right? I can tell you we have a heating block that was sold to a customer, and they were asking some questions. They were having trouble with it, but it was not trouble. It was just that they set it up for 1 hour to heat, and then we turn off, and they didn't know that they had set it up like that, so they thought it was not working correctly, right? So I did tell them to change the time to forever infinite, so that they didn't have that. It would just stay on the whole time. And I did tell them to put a thermometer to make sure that the temperature was correct. It's just a good way to check, but you don't have to always have it on the thermomixer. I would not have it, because if you want to use the mixing capabilities, my experience is that there's going to be somebody that's going to try to put tubes and everything and mix with the thermometer on, and you never know if it can break there, right? We don't. I don't want to deal with that breaking into the machine.
All right, I hope that answered your question, Don.
Leonardo, it's Sharon. I have a question.
Yes.
You just said you can put it on for infinity, which means it just keeps going continuously. You don't have to set a time. Is that correct?
So I was talking about heating blocking that time. I think that's a good question.
Leonardo,
Yes.
this is Tanya from BioLinks. I looked it up on the specifications, and it can be programmed up to 99 hours. So I think that's more than sufficient for overnight.
Yes. Thank you, Tanya.
All right, that's it for.
It is really nice because you can turn it on and off, right? You turn it on when you go to work, and then you turn it off. One thing that we try to tell the customers, we try to be eco-friendly, so it might be good for you to set up like a timer, right? You put a time, one of those things that you can set it up so it turns on, let's say 8 in the morning, it turns off automatically at 6 or 7 p.m. Because that will be, it's more ecological, you're more friendly, and you're not wasting electricity. So I'm a big fan of not keeping it on all the time if you're not using it. It extends the life of the equipment a lot, and that's true for any equipment. So I recommend people to turn it on and off when you are in the lab. Don't leave it on all the time, because you're wasting electricity. So, and unlike a water bath, this will heat up fairly quick. It has 2 Peltier elements. So
All right, great. Thank you, Leonardo. That's great. That'll conclude the session for today. I want to thank everyone for coming and sticking with us. And I hope this instrument could maybe be beneficial for you in your lab. So please don't hesitate to contact us with any questions, quote requests, or if you'd like a one-on-one with Leonardo for your application. So your rep will be contacting you after the session with the recording and confirm the address that we have for you, so you can get your Tim Hortons gift card as well. Thanks, everybody. Have a great Wednesday.
thank you.
Thank you for
Thank
coming,
you.
everybody.
Thank
Have a
you.
wonderful Wednesday. Nice to meet you.
Thank you.
Thank you,
Thank you,
everybody.
Leonardo.
Thank you.